doesn't work. So other years, this would have been one of the first conics we did after we talked about circles, but we're doing things a little out of order this year. But the reason they're called conics, I don't know if I mentioned this in this class, I mentioned it in some, is because you can slice a cone. Look at how they've taken that, what's called a double napped cone, or two cones stuck together at their vertices, at their tip there. But if you cut parallel to the base, you get a circle. If you slant it just a little bit, you get an ellipse when you cut it. Okay, if you put it on the meat grinder and sliced it at a little bit of an angle, you'd get an ellipse. We have talked about both of those. Today we're going to talk about a parabola. A parabola is when you slice it parallel to one of the slant heights, okay? So parallel to this slant height here, you would get a parabola. And then next week we're going to talk about hyperbolas, okay? Because the rest of this week is kind of messy, right? We're going to finish parabolas Thursday. All right. This is the general form for all conics. We have seen that they will write, whoa, I don't know what I just did. They will write this form, okay? What is the one thing we have not had? Does anybody know? Yeah, we have not had an XY term, and we are not going to have an XY term. That XY term would take any of these conics and slant them. So your parabola would go maybe like this, off at an angle, okay? Yeah, we're not doing those. Fancy geometry definition, okay, for a parabola is that all the points on the parabola are the same distance from this line as they are from the focus point. And that line is called the directrix. Let me show you here, okay? So if this is highway, we'll say this is 90, okay, the interstate, and this is your business, and you're trying to figure out how to reach all the people that go a certain distance or something. Now, obviously, this point is the middle of those two things, right? But if you wanted a place where it's the same distance from your business, maybe you're going to open a second location, okay? And you want it to be the same distance to your new location as it is to get onto 90, for the trucks to get onto 90 that are delivering your whatever you're making. What happens is you get a parabola. So the distance from here to here is equal to the distance here. Does everybody see what I'm attempting to say? All the points that make the parabola, any point on the parabola is the same distance from here, the focus point, this is going to be called, to this line, and that's called the directrix. You should have in Algebra 2 had those two words, focus and directrix. Does that sound vaguely familiar? Maybe. Some of you is a no-no. Okay. So what do you notice about this directrix line? Is it going through the parabola? Never, okay? The parabola opens away from that directrix. It is, in fact, perpendicular to this line. What's that line called? Axis of symmetry, okay? So it would be a right angle to this directrix. And this focus point is a point inside, and we're going to talk about, that's a very important point. The focus point has to do with the use of a parabola as well. I'm going to show you a couple things about that. But this, one more thing before I switch this side, this little distance here, from here to here or here to here, is actually P, and that's a variable we're going to talk about. All right, back here there was something at the bottom, and I'll be real honest and tell you that I did not click on this one this morning when I was previewing this. Oh, this is just interactive, I think. We can like drag this and see that this distance stays the same. We can change this focus. What happens the closer the focus gets to the vertex? The narrower it gets, yes. The further the focus is from the vertex, the wider open the parabola is, okay? But this distance, can we change the vertex? It doesn't look like it. Okay. So we can drag things along here. Same thing, okay? The directrix and focus stay the same distance away from the parabola. All right. Then I have, it says if a material that reflects light is shaped like a parabola, the light rays parallel to its axis of symmetry will be reflected to its focal point. Conversely, if the light comes from the focal point, the focus, then it gets reflected parallel. This works the same for light, sound, and other forms of energy or whatever you're talking about here. So what it's saying is that if you put a light bulb here, and this is the reflector of your headlight maybe, okay, then what happens is it bounces off and reflects out at a parallel to the axis of symmetry. So that's helping to determine where the light rays go after they leave your headlamp. I do have a couple other examples here. It talks about where do you think this receiver is placed? The focus points, okay? And here, I don't think this is clickable. It just talks about this distance. And there's satellite dish is a perfect example of parabolas. Here's a headlamp. Okay, the inner surface is smooth, made of glass, which is a powerful reflector. The light source is at the focus, and they will be reflected parallel. This is also a parabolic shape. Okay. These would be these little support cables would all be parallel to the axis of symmetry. And here's throwing something in the air with a certain force, waterfalls in a parabolic shape. Pretty cool, right? All right. So this is an equation. Do you see that on your reference sheet somewhere? Can you look for that? I think that equation is right smack at the top, right? Of those boxes for parabolas. All right. The ones where x is in the squared quantity, okay, open up and down. Those are the ones we're used to, right? Y equals 2x squared plus 6x minus 8. We know that's going to be a parabola. It's going to open up because the 2 is positive, etc. When it's the y that's in the squared quantity like this one, it opens sideways, and those are the ones that are brand new to us. Okay. Let's see. In this lesson, you'll refer to parabolas as curves that open up, down, left, or right. In calculus, you will use the term concavity, concave up, concave down, etc. All right. So this is what vertex form look like. And if you talked about these last year, you used this idea of 1 over 4p. And this one would be sideways, which nobody did last year. Okay? So this is kind of vertex form, but we are not using vertex form. Do you see that the 1 over 4p has not been divided over to the other side? The 4p is on the non-squared side. Does everybody see what we're talking about? The squared is over here. The 4p goes here. All right. So here, look where it says h plus p is the focus. That's because, again, that distance from the focus to the vertex is called p. So the difference between the focus and the vertex, as everybody see here, is a distance of p, and here is a distance of p. And the directrix is the vertex minus p. All right, so I just want you conceptually to understand what p is. All right, you have this example. I don't know if it's done for you. This is the x and y axis way up here. So this focus point, they've graphed it. All right, let me go through it. So this would be x minus h squared equals 4p times y minus k. So what can you tell me? H is, the minus is part of the formula, so H is 3. K is -4. And this business in here tells me 4p equals 12, so p is +3. A p-value of +3 means it's opening in a positive direction. The x was squared, so it's opening either up or down. +3 would mean it's opening up. Okay? The vertex would be at 3, -4, which is over 3 and down 4. 1, 2, 3, 4, right here. That's the vertex. And then the fact that p is 3 means the distance to the focus point is 3. So what's the formula say on your reference sheet, guys? When it's x minus h squared, the focus says what? So that was 3, -4 plus 3, which is 3, -1, which is over 3 down 1, which is this focus point right here. The directrix is a line that is behind or underneath or whatever the parabola by the same distance p. So it's 3 units below this. The equation for directrix when it opens this way is, so y equals, k was -4 minus p, which was 3. So we get y equals -7. Now p has a sign that's very important you bring with it, okay? This one was a positive, but be careful. So it is down here. Does everybody see that that's crossing the y-axis down at -7? And you do need to remember its equation of a line. What would the axis of symmetry be? Yeah, it's x equals through the vertex here. Everybody good? All right. You have this problem? Okay. So I'm going to write right underneath it. Be careful. It's y minus k. Remember we had this issue with ellipses that we can get the h and k backwards. And then 4p x minus h. I just copied that off the reference sheet. Everybody see that? Okay, so what can you tell me? Martin, tell me something. You can look up here. What can you tell me? Can you tell me what h or k or p is? Okay, so if this is equal to this, then p is +2. Brandon S., can you tell me something? Good job. Destiny, can you tell me something? Xavier, can you tell me which way it's going to open? It's actually not going to open upwards because the y is in the squared. So you're using the one on the right. Okay. And because p is greater than 0 or positive, it will open to the right. Everybody see underneath on this, this slide. Do you see it says here when p is greater than 0, it opens to the right, less than 0 opens to the left? Or if the x is squared and p is greater than 0, up and down? We good? Where we're getting that? All right, so Cameron, tell me the vertex. Be real careful. It's HK, so it's 3, -1. There we go. 3, -1 is the vertex. Okay. How do we find the focus, Aislinn? Can you tell me? The focus, it says h plus p comma k. So what would that be? What was P? P was 2. Yes, good. 5, -1. So over 5 and down 1 is our focus. And remember that meant this distance is actually P, which was 2. Okay. And the directrix, anybody? Directrix equation is h minus p, so it's x equals 3 minus 2 is 1. It is a line that should be 2 units this way. X equals 1. Does that seem okay with everybody now? Okay, the hardest part of these, and I did not do this on the example, the hardest part of these is finding another ordered pair to make this nice. Here's my hint for finding another ordered pair. You want to go out a couple units, okay? And you want to put in whatever value is squared, I think. So, what's a couple units away from here that's a y value, guys? So if I were to go a couple units this way, what would the y value be right there? 1. Now that's not a point, I'm just checking. So if I put in a y value of 1, I'm going to find an ordered pair that looks like this. Everybody agreeing with me? Okay, so I'll have 1 plus 1 quantity squared equals 8 parenthesis x minus 3. What's 1 plus 1? 2 squared is, so I have 4 equals 8 times x minus 3. What could I do? I can distribute, but I could also do what? Divide by 8 and get 1/2. And then add 3 over there and get what? 3.5. So if I go over 3.5, I'm up 1. Not a very nice point, but do I know another point now? I don't have to write the ordered pair, but, well, I would go, yes, 3.5 this way, and then the same amount on the other side of the axis of symmetry. Everybody good? All right, that didn't get us very far, but can we tell it's not very narrow? Who said we should put in a 3? Did Brandon or somebody say we should do 3 for the y? I think 3 for the y might have turned out real nice. 3 plus 1 would be 4 squared would be 16. Then we would have divided by 8 would be 2. Add the 3 over and we would get 2 plus 3 is 5. So 1, 2, 3, 4, 5. It's up at 3. Does that seem like it might be doing the right same loop as the last point we found? So it was 1, 2, 3, 4 units away from the axis of symmetry. So it would be down here is the other one. All right, so finding points to graph accurately is actually one of the hardest things. If it's an x equals, like this one would be, you can't type it in your calculator, right? If you could get the y by itself, like you can on this one, you could type it in your calculator to get some points. Everybody see what I'm talking about? We could divide the 4 over here and then add the 1, and you could type it in your calculator. All right, but we're going to continue to do it the same way we are. All right, this time it's x minus, I didn't write it right, x minus what? H squared equals 4p times y minus k. Haley, tell me something. Can you tell me k while we're at it? Good job. Jacob, can you tell me something? P is 1. Everybody okay with that? 4p equals 4. Which way does it open, Isabella? Yes, it is an x squared parabola, so it opens either up or down, and p is +1, so it's going to open up. So where's the vertex? Anybody? Okay, and they're using this crappy graph paper again. Here is -2 up 1. All right. You have to tell me the focus and directrix as well on the quiz, and then you got to find some points. Focus, anybody? What is the equation for focus when it opens this way? H comma K plus P. Well, if P is 1, I should be going 1 unit up. So if I put that in there, -2 comma 1 plus 1, which would be -2, 2. Everybody good that that's the focus? Which is on this crummy graph paper right at this spot in here, just barely inside. Which means the directrix is 1 unit the other way. Formula is y equals k minus p. Y equals 1 minus 1 is y equals 0. Is this x-axis is the equation y equals 0? All right. What are some points we might put in? Are we going to put in numbers for x or y this time? X. Always put them in the squared quantity. All right. What do you want to pick for x? 0 is actually 2 units away, right? We could pick 0. We could also pick 2, somebody said. All right, if I put a 0 in for x, I will have 2 squared equals 4 times y minus 1. 2 squared is 4. If I divide it by that 4, right? What will I have? 1 equals y minus 1, which we add the 1 over there and get 2. Add 1, right? Okay, so if we go over 0 up 2, or we go to the other side and up 2. Oh no, that's not right. No, it is right. Just kidding. Up 2 from the origin, or from the, I'm okay. It's an ordered pair. We're not going conceptually 2. We're literally going up 2. All right, if we put in a 2 for the x, it would say 2 plus 2 quantity squared equals 4 times y minus 1. Okay, this would be 4 squared, which would be 16. Then what do you want to do? Divide by 4. Add 1. Did anybody get 2, 5? So 2, 5 would be up here. And going this way would be somewhere in there. So everybody get what I'm doing with the second one I'm drawing in red or in blue? It's just going the opposite side of the axis of symmetry the same amount. So this one is much narrower. Do you remember the slide where we got to drag things around on the website? It showed when we made the focus and directrix closer together that it was skinnier. Yes? Okay. The smaller p is, the narrower it will be. All right, number 3, you have this one. Can you try this one on your own? I think p is getting real small now. Anybody have a vertex for me? Anybody tell me which way this opens? I believe to the right is correct. All right, so when I look at my sheet for opening to the right, the focus, whoops, is at H plus P comma K. Did anybody do that yet? It is 6.53. 6.53. Ooh, yeah, I can't even show 6.5 with this crummy graph paper. The directrix, anybody come up with that equation yet? Oh, I did the... No, it's x minus h minus p, isn't it? Because it's opening sideways. So 5.5 or 11 halves. So here's 4, 5.5 would be super close to the vertex here. So since these are so close together, is it going to be skinny or wide? I think it's going to be skinny, yes. So we need to find some points. Are we putting in x or y? Again, this is the tricky part. We're going to put in y values. And we're going to put in a couple units above and below. The y value here was 3, right? So what's a couple units above or below? 5 and 7 maybe? If we wanted to do 2, you don't have to do 2, but you have to do at least 1. All right, if I put a 5 into the original, I'm going to get a point now that ends with a 5 because the y is 5. Okay, so 5 minus 3 squared equals 2 times x minus 6. This would be 2 squared is 4. And then what? Can I divide by the 2 real quick? Add that over and I get, so I have 8, 5. So over to this line and up. So 5 would be here. So can you tell where the other one would be? Should be 8, 0, right? Or 8, 1. Okay, thank you guys. Are you sure? This wasn't this halfway? Was up 6.5. So we went up another 1.5 and over. Oh, the vertex is at 6.3 to 6.5. Oh. Did I still graph it right? One, 2. Okay. 1, 2. I gotcha. Yes. Okay. Yeah. I went up 1, 2 because it's a whole block. I should be going down a whole block, not a block and a half. I gotcha. All right. Yes. Horrible graph paper. All right. I'll try putting the 7 in my head here, see if we can get one more ordered pair. It would be 7 minus 3 would be 4 squared. And it would end in a 7. This would be 16 divided by 2 is 8, plus 6 is 14, 7. So 14 is here, and you'd be up at 7, which was from the middle 1, 2 whole boxes. I think it would be there. That seems about right, doesn't it, if I went out another point? All right. Those are so fun. What's happening here? Yeah, the P is not where we want it. They messed with us. Because our paper says x minus h squared equals 4p y minus k. So what do we need to do? Multiply the what over onto the other side? Yes, the reciprocal. So it's going to become x minus 3 squared equals negative 12 y minus 6. I'm going to multiply through by a negative 12, basically, to get rid of this fraction. All right, so h is 3, k is 6, p is what? I feel it's the first time we've had a negative p, yes? Okay, so we have to be real careful. Which way is this guy opening? It's going to open down, okay? Vertex, anybody? 3, 6. 2, 4, 6. 3, 6 is up here. If p is negative 3, can you conceptually tell me where the focus is? It's 3 units which way? Down. So it should be here. The formula for focus is h comma k plus p. So we'd have 3 comma 6 plus negative 3, which would be 3, 3. And the directrix, the formula is y equals k minus p, which is y equals 6 minus negative 3. So you get y equals 9. If I would have done that wrong, how should I have figured out that something was wrong if I got y equals 3? Away from the directrix, and the directrix should be on the other side of the vertex, right? So if this is the vertex and this is the focus, the directrix has to be up this way. What's wrong with my focus, guys? I found the right ordered pair here, but I graphed it wrong because I went 3 boxes, right? I hate this graph paper. Okay, so 3, 3 should have been here. And 9 is up here. And remember to draw and state that the directrix is a line, okay? The directrix here is an equation, y equals 9, and it is a line that you draw, not a point. All right, then the hard part. We got to find an ordered pair. What are we going to put in, an x or a y? We're going to put in an x because that's the squared. Okay, the x right now of our vertex is 3. What's a couple units away from 3? 5. We could put in a 5 or 7. Okay. I say a couple units because it just seems like it works out better. You definitely don't want to get too close to the vertex. You're not going to be able to tell how much it's stretching. All right, if I put a 5 in, is it okay if I put it in our fixed one, guys? Actually, it might be better to use this one, but it doesn't really matter. If I put a 5 in, I will have 5 minus 3 squared equals negative 12 y minus 6. This would be 2 squared is 4. Uh-oh. What do we get? Can someone do negative 1/3 plus 6 would be 5 2/3, right? Or 17/3. Did anybody get that? Okay, so it's over 5 and up 5, 2, 4, 6. What am I doing? Oh, 5 2/3. Wait a minute. Okay, here's 5. Here's 5. 2, 4, 6. I think it's very wide, yes? Okay, so then this way would be here. Wouldn't it be where it crosses? One square, one, yeah, here. Is that right? Should not be on the y-axis. All right, I want to go out further. Can we do 7? If I put in a 7 here, I'll have 7 minus 3 is 4, squared is 16, equals 4, equals negative 12. Sorry, the p was y minus 6. Okay, this is not coming out nice either. What is 16 divided by negative 12? What, negative 1.25 or something? 1.3? Okay. Add 6. 4 2/3, which would be lovely. Yeah, just to make life even more miserable. So if we go out 7, we are up at 4 2/3, 2, 4, and a little more. It's really flat. Is anybody else getting that idea? Anyway, we probably should have gone out to 8 or something. Maybe it would have turned out nicer. All right, moving on. These are a couple quick questions where we have to go backwards. Specific characteristics can be used to determine the equation of a parabola. Write an equation for a graph, the parabola with the focus here and the vertex here. I would have to graph those, but you could also look, what stayed the same, guys? The y value or the k. Which focus and directrix have the same k when it opens sideways, right? Now, you wouldn't get a picture probably with this. I would have just said -4, -3 and graphed it. And 1, +1, -3 was the vertex. I would have graphed and said, oh, well, if this is the focus and this is the vertex, it's got to be opening to the left. All right. So if this is the vertex, H is what? There's H and K, vertex. So H is 1, K is -3. Okay, now we got to figure out P. When it opens sideways, the focus equation is what? H plus P comma K. So 1 plus P comma -3 became, what was the focus of this one? -4, -3. So what can you tell me? 1 plus P equals -4. P is -5. This distance should be 5. Okay. This graph paper is lovely. It goes by 2's up and down and 1's across. Okay. So we need to write in the equation. So once we found P, all we have to do is fill it in. We figured out it's a sideways opening one, so here's the sideways. So what should it be? Y minus K would be +3. That quantity is squared. 4P would be -20. And then X minus H, which is, everybody got it? The directrix would have been way back over here somewhere. All right, so we're going to try this. Is this the same problem? No? Okay, -1, 5. Oh, hating on the graph paper again. And the vertex is +2. That's the focus. +2, 5. So if that's the vertex, I don't care about the graph, but tell me. It opens to the left because the vertex and focus, right? That's all we care at this point. So what else can you tell me? General form would look like y minus k if it opens left and right. 4p x minus h. What else can you tell me? H is? H is 2, k is 5. Okay, when it opens sideways, the formula for focus is h plus p comma k. So what do we have? 2 plus p comma 5 equals, what is our focus point? Okay, so then I have 2 plus p equals -1, which would make p -3, right? If we subtract 2 from both sides. Which, does that make sense? Is this a distance of 3 from here to here? And it's opening in the negative direction because it's opening left. That all checks out. So what's the final equation? Do I have one more? Okay. This says it opens down and the vertex is at 5, 3. What can you tell me? And y equals 6 would be up here is the directrix. I actually know everything already because this is h and this is k. If it opens down, the equation is x minus h squared equals 4p y minus k. Can you tell me conceptually the distance from this to this is how far? 3 units. So that means p is 3, except it opens down, so it's -3. So it would be x minus 5 squared equals -12 y minus 3, because k is 3. And again, you could have found that using y equals k minus p. And working backwards, it said this is 6 up here, and k was 3, so we would have subtracted and said p is -3. All right. Oh, there was another one I didn't get to. Same difference. Sorry. So these are the questions. Okay, I am not impressed with the homework, especially considering that we had a work day. Okay, let me take that back. Adriana, I am very impressed with homework. Okay, but some of you should have all turned something in. You had a whole work day. Now, and the most important thing in my opinion is you got to be doing this a little every day. You can't do it all the day before the quiz because you don't remember. So please do this tonight. I'll see you tomorrow. We do have class, right? Only 5th period I don't have tomorrow.